Good afternoon, everyone. Today, I would like to talk about the 2015 Nobel Prize in Physics. I chose this topic because it reveals that even fundamental particles can change their identity. The prize was awarded for the discovery of neutrino oscillations, which shows that neutrinos have mass. Neutrinos are extremely small particles that rarely interact with matter. For a long time, scientists believed that neutrinos had no mass. However, experiments showed something unexpected. Neutrinos can change from one type to another as they travel. This phenomenon is called neutrino oscillation. There are three types, or flavors, of neutrinos: electron, muon, and tau. As neutrinos move through space, they can transform between these types. This behavior can only occur if neutrinos have mass. Therefore, this discovery changed our understanding of particle physics. It showed that the standard model was incomplete. This finding has important implications for our understanding of the universe. Neutrinos are very abundant and play a role in cosmic processes. I find this discovery very fascinating because it shows that even the smallest particles are not fixed. It also teaches us that change is a fundamental property of nature. In the future, further research may reveal more about the role of neutrinos in the universe. Even though this topic may seem abstract, it gives us an important message. Nothing is completely unchanging. Thank you.
Good afternoon, everyone. Today, I would like to talk about the 2015 Nobel Prize in Chemistry. I chose this topic because it explains how living organisms maintain the accuracy of their genetic information. The prize was awarded for mechanistic studies of DNA repair. DNA carries the genetic instructions necessary for life. However, DNA is constantly damaged by various factors. These include radiation, chemicals, and even normal cellular processes. If this damage is not repaired, it can lead to mutations. Mutations may cause diseases such as cancer. Fortunately, cells have developed several repair systems to correct DNA damage. One important mechanism is base excision repair. This system removes damaged bases and replaces them with correct ones. Another mechanism is nucleotide excision repair. It removes a larger section of damaged DNA and rebuilds it. There is also mismatch repair, which corrects errors that occur during DNA replication. These systems work together to maintain genetic stability. Without them, life would not be able to sustain itself. This discovery has had a major impact on biology and medicine. It has improved our understanding of how diseases develop. It also helps in developing treatments, especially in cancer therapy. I find this discovery very fascinating because it shows that biological systems include built-in error correction. It also teaches us that maintaining accuracy is essential for survival. In the future, this knowledge may lead to new medical advances. Even though this topic may seem complex, it gives us an important message. Correcting errors is just as important as creating information. Thank you.
Good afternoon, everyone. Today, I would like to talk about the 2015 Nobel Prize in Physiology or Medicine. I chose this topic because it shows how medical discoveries can save millions of people from deadly infectious diseases. The prize was awarded for discoveries concerning a novel therapy against infections caused by roundworm parasites and for a novel therapy against malaria. At first, this topic may sound very medical, but its meaning is easy to understand. Parasitic diseases have harmed humanity for a very long time. Among them are infections caused by roundworm parasites and the disease malaria. These illnesses have affected especially large numbers of people in poorer regions of the world. For many years, treatment was limited, and many patients suffered or died. One major part of the prize concerned infections caused by roundworm parasites. These parasites cause serious diseases such as river blindness and lymphatic filariasis. Scientists discovered ivermectin, a powerful substance that led to highly effective treatments against these roundworm infections. This was a breakthrough in anti-parasitic therapy. It greatly reduced suffering and helped protect millions of people from disabling disease. The second part of the prize concerned malaria. Malaria is caused by parasites transmitted by mosquitoes, and it has killed enormous numbers of people throughout history. Scientists discovered artemisinin, a drug derived from traditional Chinese medicine. This treatment became a highly effective therapy against malaria. It saved countless lives, especially in regions where malaria had been a major threat. These discoveries were extremely important. They showed that careful scientific research can produce powerful therapies against major infectious diseases. They also demonstrated that both modern laboratory science and traditional knowledge can contribute to medical progress. I find this Nobel Prize very inspiring. It shows that medicine is not only about understanding disease, but also about finding treatments that reach people who need them most. It also teaches us that even diseases affecting the poorest populations deserve the highest level of scientific attention. In the future, this knowledge may help scientists develop even better therapies against parasitic and infectious diseases. Even though this topic may seem specialized, it gives us an important message. Science can directly reduce human suffering when it turns discovery into treatment. Thank you.